Hello, and welcome to this presentation, Understanding Audio Cables. In this presentation, we'll provide a brief introduction to the most common types of analog audio cables used in test and measurement applications. There are a number of test and measurement instruments that use audio interfaces and cables. The most obvious examples of this is audio analyzers. But audio connections are also very common when using two-way radio test sets, as well as signal generators. In some of these cases, the audio is simply an information source. For example, when audio is used to modulate the output of a broadcast signal generator. In other cases, the audio signal is being measured or analyzed, such as measuring the total harmonic distortion present in the audio output of a two-way radio, or the synad of a radio receiver. In both cases, different types of physical interfaces or cables are used to connect instruments and devices under test. And in the remainder of this presentation, we'll briefly cover the most common audio interfaces and cables used in test and measurement applications. Audio cables can be characterized in two main ways. The first is whether the cables are used to carry unbalanced or balanced signals. The second is the number of conductors and the physical connector on each end of the cable. Since some types of cables are only used for balanced or unbalanced connections, and some cables can be used for either, we need to start by explaining what we mean by unbalanced versus balanced cables. Unbalanced cables are very common in consumer electronics, in part because these cables tend to be physically small, lightweight, and low cost. In an unbalanced cable, the signal is carried on one conductor, and the signal is referenced to ground. The largest issue with unbalanced cables is that these cables can act like antennas and pick up external noise, especially since these cables often have little to no effective shielding. Unbalanced cables generally should be kept as short as possible in order to minimize noise pickup, but this inherent susceptibility to noise means that it's best to avoid unbalanced cables in test and measurement applications whenever possible. Balanced cables, on the other hand, have three conductors, two signal lines, and a ground connection. Note that the shield may be connected to ground on both ends, as shown here, or on only one end, typically the sender end, in order to avoid ground loops. The same signal is present on both lines, but with different polarities, often referred to as plus and minus. This arrangement provides much greater immunity to noise, because noise can be easily removed or canceled out using a differential amplifier on the receiving end. Balanced cables can therefore be used over longer distances, that is tens of meters or hundreds of feet, and can also be more easily amplified without also amplifying noise. Because of these advantages, balanced audio signals are preferred in test and measurement applications whenever possible. Now let's look in detail at the four most common cables in test and measurement. These are tip ring or tip ring sleeve, XLR, RCA, and BNC. We'll start by looking at the tip ring family of cables. The reason for calling this a family of connectors is that there are actually three variants. The first is the TS connector, whose plug consists of two electrically separate sections, the tip and the sleeve. The other common variant is called TRRS because it has three conductors, tip, ring, and sleeve. Both of these plugs are found in the larger quarter-inch and the smaller eighth-inch diameters. The larger diameter is most often seen in professional audio applications, whereas the smaller diameter is more commonly used for headphone, line, and aux jacks in consumer devices. The third variant, TRRS, has two rings in addition to the tip and sleeve. TRRS cables are usually found only in the smaller 1/8 inch size. Over the next few slides, we'll cover each of these variants in more detail. TS cables have only two conductors, tip and sleeve, and this can only be used to carry a mono, unbalanced signal. The conductors within the cable can, however, be arranged in two different ways. So-called instrument cables have the center conductor connected to the tip and the sleeve connected to a woven shield that surrounds this tip. The shield is connected to ground, and this helps to prevent noise pickup. The other arrangement is a speaker cable, which has two identical conductors, one attached to the tip and one attached to the sleeve. Here, both conductors are thicker, and this allows them to carry higher current. But the lack of shielding makes them more susceptible to external noise pickup. Because they're unbalanced, TS cables are not recommended in test and measurement applications. But if they are used, then instrument cables should be used whenever possible. As mentioned earlier, TRRS cables have three conductors: tip, ring, and sleeve. These three conductors can be used or assigned in two different ways. The first of these is making a balanced mono connection. In this configuration, the tip is signal plus, the ring is signal minus, and the sleeve is connected to the shield/ground. The other way that TRRS cables can be used is for unbalanced stereo connections. Here the tip is left audio, ring is right audio, and the sleeve is connected to ground or chassis. It's worth noting that the larger 1/8" TRRS cables are almost always used to carry stereo signals rather than balanced signals. TRRS cables have four connections: tip, two rings, and a sleeve. This cable is used to carry stereo in one direction, with the left, right, and ground conductors assigned as shown. The fourth conductor is used to carry a mono microphone signal in the opposite direction, with ground being shared between all conductors. TRRS cables are almost exclusively used with headphones that also have a microphone input, and thus this is not a common connector in professional or test and measurement applications. And as mentioned earlier, these cables are almost always 1/8" or 3.5 millimeters in diameter. Although the conductor assignment shown here is the most common, the pinouts of TRRS cables may vary between different cable and device manufacturers. The next cable type is XLR, which is a 3-pin connector. Pins 2 and 3 are the signal plus and signal minus conductors, since XLR cables are used to provide a balanced connection. Pin 1 is connected to shield or ground. You may sometimes hear XLR cables referred to as microphone cables, because the balanced shielded connection is advantageous when carrying microphone-level signals, which are relatively weak and thus more susceptible to noise. Note that XLR cables are used for mono connections. That is, there's only one channel per cable. An additional advantage of XLR cables is that they can be physically locked into place. But it should also be noted that not all XLR cables, or jacks, support this locking mechanism. Unlike XLR cables, which are most often used in professional environments, RCA cables are used almost exclusively for consumer or home audio applications, in part because these cables are physically small, flexible, and relatively inexpensive. In most cases, RCA cables are paired for carrying stereo signals, with the standard color arrangement being red for the right audio channel and white for the left audio channel. Since each cable has only a single conductor and ground, RCA cables are unbalanced. They should only be used in electrically quiet environments, and cables should be as short as possible. For this reason, analog RCA cables are not commonly seen in test and measurement applications. However, RCA cables can also be used to carry digital audio, SPDIF signals. In this case, only a single RCA cable is used, which is usually colored orange. Please see the separate presentation, Understanding SPDIF, if you'd like to learn more about SPDIF digital audio cables. The last cable type we'll look at is BNC, which is a two-conductor, unbalanced connection made using coaxial cable. Here, the signal is carried by the center conductor, and the shield is connected to ground. For various reasons, BNC is uncommon in professional or home audio applications, but it's very commonly used in test and measurement, particularly when making audio connections to unbalanced devices, such as the audio in and out of two-way radios. Even though they're unbalanced, BNC cables provide excellent resistance to noise due to their locking connectors and typically robust outer shield. It should also be noted that BNC cables and connectors used for carrying audio should have a 75 ohm impedance. This is different than the more common 50 ohm impedance in most other test and measurement applications, although depending on the application and the audio levels, this impedance difference may or may not have a significant effect. Let's end with a brief summary. Various types of audio cables and connectors are used in test and measurement applications, and in this presentation we looked at the most common ones, namely TR/TRS, XLR, RCA, and BNC cables. These cables are most often used either to connect instruments to an audio frequency modulation source or to a device under test, such as a cell phone or two-way radio. Generally speaking, balanced three-wire cables are preferred over unbalanced two-wire cables, because balanced cables offer better immunity to external electrical noise and can also be used more safely over longer distances. And finally, we mentioned that although BNC cables are unbalanced, they can also often provide good immunity to noise due to their locking connectors and typically robust outer shield. This concludes our presentation, Understanding Audio Cables. If you'd like to learn more about audio testing and related instruments from Rohde & Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.